Good day, dear viewers. You're welcome once again to our channel. My name is Ayolua, and if you watched the last video, we introduced by telling you that this channel is dedicated to learners out there that are struggling with physics. Alright, so today we'll be looking at a topic which is fundamental and derived unit. Fundamental and derived unit. Alright, before we continue, for you to make something meaningful of this lesson, of this class, I'd like you to get some useful materials, which is your pen, your notebook, and your readiness, and then your listening ears. Okay, let's start with the definition of fundamental quantity. Fundamental quantity are the basic quantity upon which other quantities depend. Now, they are the basic quantities that are independent of other quantities. We also have the meaning of fundamental unit. Fundamental units are also the basic units upon which other units depend. Just like the definition of the quantity, the unit is also added. So let's look at the examples of fundamental quantities and the unit. The first one we have here is length. Length, and the unit of length is meter. We have time, the unit is seconds. We have mass, the unit is kilogram. We have electric current, the unit is ampere. We have temperature, the unit is Kelvin. You see, you need to memorize all these units. Why? Because going forward, you have need of them. Okay, so when we say it is a fundamental unit, you see length now does not depend, it doesn't, when we get to derived, you understand what I'm saying better. Does not depend on anything. It just has a natural unit on its own. Length, when you're talking about length from here to here, the unit, okay, from here to here, you're talking about 10 what? 10 meter. You get what I'm saying? Okay, so the same thing as mass, time, electric current, temperature, and so on. Okay, we also have derived unit and quantity. Derived quantity, can be defined as the quantities that are obtained by the simple combination of what? Fundamental quantities. The same thing as units. Derived units are gotten, are obtained from the simple combination of fundamental quantities or units. Now, these are examples of derived quantities and their units. The first one here we have area. How do we get, the unit? From length times breadth. Length times breadth. Don't forget you're having area, length times breadth. Using a rectangle as an example. Don't forget length is distance expended. So this is a distance, this is a distance, this is also a distance. They are all measured in what? In meter. We only use the longest side. We only use length to represent the longest side and use breadth to represent the shorter side. So now you're having length times breadth, which is meter times meter. Then it gives you the unit of area as meter square. M times M, that's meter square. The same thing goes with volume. Volume, that's length times breadth times height. Length is in meter, breadth is in meter, height is in meter. So you're having M times M times M, that's M cubed, M raised to power 3. Then we're having density, mass over volume. Don't forget, I told you the other time that the right quantities are obtained by what? The simple combination of what? Two or more fundamental quantities. This mass here is a fundamental quantity. Volume here too, we got it length and breadth and the combination of fundamental quantity. So now, since the unit of we having mass over volume, the unit of mass from our fundamental quantity is kilogram, and then the unit of volume, which is m times m, that's m raised to power 3, gives us the unit of density as kilogram per meter cube. You can write it like this, or you write it kilogram Do you get it? This one is, your understanding of indices. Okay, all right. The same thing goes with velocity, displacement over time. Your distance and displacement are, similar. Anyway, we talk about in our upcoming videos the difference between distance and displacement. So displacement is measured in meter, while your time, a fundamental quantity, is measured in seconds, which gives us meter over seconds. So you can write it as m/s, meter per second, or you write it as meter per seconds. Any of these is accepted. Okay, so we have acceleration as change in velocity, and change in velocity over time. Change in velocity over time. Don't forget your velocity is measured in meter per seconds. Meter per seconds. Let's use this one, meter per seconds. Then over time, which is also in seconds. So from your understanding of indices, you have a meter per second squared. So you can write it like this, or you write it like this. Any of the two is accepted. That brings us to the end of today's lesson on fundamental and derived unit. If you have any question, you are free, to go to the comment section and ask, or you chat me up on my WhatsApp line 090 29 41 80 62. I believe you have learned something today. If you have actually learned something today, if this video is useful for you, please like, comment, share, and also subscribe to our channel. Stay tuned for upcoming videos. Thank you very much.